Hi everybody, this is Han Guang. You can also call me Gloria. I'm here to present the result of my research about the predicting future visitors of Japanese restaurant. So the aim of this project is to predict the future numbers of restaurant visitors. The data was collected from Japanese restaurants. For this project, I would focus on simple forecasting, only use the data set called air visit. I noticed that in the project description mentioned the effect of the holiday, and I would address that in my later work. The initial requirement of this challenge is to predict future visitors for each different store. So I took the store with ID air blah 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 24 for an example. Some problems appears here. So the data is not continuous in time. Also, the plot doesn't show the obvious impact of holiday. So that is maybe because we have too little data to make it more obvious. Therefore, I determined that instead of forecasting for each store, I will forecast the visitors of all the stores as a whole. The plot of daily visitors shows that this graph reflects a kind of weekly pattern, as we can see the predicted golden week of 2016, which shows slightly before the week 20. It shows a smaller fluctuating, so indicating that we should consider the effect of holiday. Additionally, I found that there's a big step between week 20 and week 40, so I'm going to transform our main response variable visitors in order to eliminate this effect. So I also so in order to examine the weekly pattern, so I took aggregate the date based on the weekday and also by the months. So the weekday, we can see that the number 1 and number 7, which is Sunday and Saturday, it has highest score. That is reasonable, and the Monday has the lowest, so they do have a fluctuating pattern. So by the months, there's not much to examine because the difference scale is small. So we should take the TS form when we should consider the frequency to be 7. So I checked the influence of holiday by introducing holiday dummy variable and fit the TS linear regression to it. However, the coefficient of holiday dummy, we can see from the graph, it is not very significant, which means the holiday effect is not very significant to be examined, so we should ignore that. I decided to use both ETS and ARIMA model because they're the two most widely used models for sale and also for restaurants area. Another problem that I mentioned before is to transform the response variable visitors. So let's look at the actually model fitting for the ARIMA. There's two ways to do the transformation. One is log and one is difference. So the graph that we are looking at is the auto plot of the log of daily visitors in time series. We can see that the big step has been eliminated, but not very good enough. And this is the difference, the auto plot of the difference of daily visitors. The big step question is solved. It's shown as a big outlier, and we can eliminate by TS clean command. But the seasonality has the potential of become bigger, which is not stationary. But it is also very hard to interpret if we take the log of the difference. So, and also I checked both of the checked residuals command, and the log has beat difference version, so I will stick to log version to do the model fitting. And for the ETS model, I will continue use to take the log version of the daily visitors and the ETS model automatically chose the model of AA, and I think the researchers perform good, but it still suffers severely from autocorrelation. And now let's look at the forecast result of these two models. So for the ARIMA model, the start point is okay. The trend of forecast looks reasonable, and however, the trend seems so strong and doesn't coincide with the same period of the previous year, which is right is is right before the big stat that we mentioned before. That that limits maybe is because that this data has not been stationary enough for auto or remote. For the ETS model, the forecast result of ETS model seem really reasonable, but less fluctuating than the same period of 2016. So I think that is a deficit of this model. So both of the two models do not capture the fluctuating trend, and in that case, they are not perfect models, but still perform good. So for the future models, I would like to put more weight on the same period of 2016, which require the knowledge of lag, which we haven't covered yet. So I hope that will help me to perfect my models in the learning of the later weeks. So by doing this research, I have the chance to know the advantages and disadvantages of ETS and the Riemann model. The exponential smoothing model are based on the description of the trend and the seasonality in the data, while the Riemann models aims to describe the autocorrelation in the data. So from this project, I have learned to link our knowledge together and use them as my own tools. I hope to learn more skills in the future weeks. So thank you guys for watching and listening to me, chatting about everything I do. So have a nice holiday. Bye.